gas law. P1 times V1 divided by T1, P2 times V2 divided by T2. All three laws at once. Okay? Temperature still in Kelvin. Now, this does actually include all three laws. If you eliminate the thing that's not involved, for example, you eliminate temperature, that's Boyle law. Okay? If you eliminate volume, that's Gay-Lussac's law. Okay? If you eliminate pressure, Charles' law. Everybody see it? So really, it's all three laws just combined. Okay? So the way it works, example problem here. Gas at 110 kilopascals and 30 degrees Celsius fills a flexible container with an initial volume of 2 liters. If the temperature is raised to 80 degrees Celsius, pressure is increased to 440 kilopascals. What is the new volume? Lots of numbers there, right? So let's break it down a little. We know this is combined. We got P1 times V1 over T1 equals P2 times V2 over T2. Okay? So we're dealing with P1, V1, T1. Let's start with that. Gas is 110 kilopascals. That's P1, 110 kilopascals. Okay? 30 degrees Celsius, that's T1, 30.0 degrees Celsius. Now, that's in Celsius. We got to change that to Kelvin, right? So, add 273. That is 303 Kelvin, okay? Fills a flexible container with an initial volume of 2.0 liters. That's volume 1, 2.00 liters. So those are all my initials. Okay? The 2's. We got P2, V2, T2. Alright? So P2. If the temperature is raised to 80 degrees Celsius, actually that's T2. So 80.0 degrees Celsius. Change that to Kelvin. Add 273. Gives me 353. Okay, 353. Pressure is increased to 440. What is the new volume? That's the thing I don't know. All right? So we have 5 numbers and 1 we don't know. So all we have to do is take what we do know, now that we know which one's which, plug it in, and solve it. All right? So I'm going to take all these numbers. P1, 110 kilopascals, divided by, times V1, 2.00 liters. Divided by T1, 303 Kelvin, equals P2, 440 kilopascals. V2, don't know, X. Divided by T2, 353 Kelvin. We good? Solve for X. I'll do it in a second, but let's see how if you guys can get it first. Okay? Everybody pull out a calculator, see if you can solve for X. Better. Ish. Like I said, guys, I'm going to walk through it, but I want to give you a chance to actually try it yourselves first, okay? So. Ready? Okay. So, I'm going to erase this stuff just so that I have any more room. Okay? All right. So first I'm going to simplify this. You can use whatever algebra method you want. I don't really care. Okay? Whatever makes sense to you. I've had people use the cross multiplying method. There's all sorts of things. Okay? There's even a matrix method out there. I don't even know how it works, but if you can make it work, do it. Sound good? I don't care how you do the math. I'm going to do it how I do it. Okay? I like to simplify that. So 110 times 2.00 divided by 303 is 0.7260726. And it kind of repeats, okay, forever. Equals. Now I'm going to simplify this. You simplify that side too. So 440 divided by 353 gives me 1.2464589 times x. Okay? So that's just doing what we have on each side. Now to get x by itself, I'm going to divide both sides by that number, 1.2464589. This makes it go away on this side, so the only thing that's left is x. That side, I'm going to go ahead and punch it in the calculator. So 0.72607260726 forever, divided by second answer. 0.5825. Okay? Now, how many significant figures do I get? Yeah. Not 3. Close. 2. This one only has 2. You see it? That has 3, that has 3, that has 3, and that one has 2 as well. So 2 is my lowest, so I'm going to round this to 0.58 liters. Okay? Questions? So just to illustrate what's going on here, the pressure is quadrupling. It goes from 110 to 440. That's 4 times. So if it was just pressure and volume, then the volume would go to 1/4. 1/4 of 2 would be half. So it would go to a half a liter. But because the temperature is changing as well, it heats it up, and so it doesn't go all the way to a half a liter. It goes to 0.58 liters. Everybody see that? 2 laws happening at once to affect that volume. Okay? Same way we've been doing it. Do you guys want another example? Yes, or yes, I'll do it or not. I got like 3 examples, but I don't have to do them all. One more? Okay. Okay, next one. Sample of nitrogen gas. Stored in a 500.0 milliliter flask, 108 kilopascals, 10.0 degrees Celsius. Gas is transferred to a 750 milliliter flask at 21 degrees Celsius. What's the pressure of the nitrogen in the second flask? Okay, so we've got V1, P1, and T1. V2, T2 is asking for P2. Go ahead and give this one a try. I'll walk through here in a minute. Yep, I screwed up. I was thinking 94, so. Thank you. So I've got the setup here. How many of you guys remember to turn to Kelvin? Okay. Equals x times, simplify that, 2.551. Okay. Divide by 2.551. One thing left is x, so 190.81272 divided by 2.5151 74.798588655. How many sig figs do I get? 3. Okay. We got 3, 4, 3, 4, and 3. So 3 is the lowest. Okay. So we round that to 74.8. It is pressure in kilopascals, kPa. Actually, a pretty low pressure. Okay? Questions? And that's the combining gas laws. Tomorrow you guys got a worksheet on it. It's basically a bunch of problems just like this. Answer keys online. You know? So that's what you're doing tomorrow. I actually switched the schedule around just a little. I did have the, I moved the quiz to Friday for one big reason. I haven't written it yet. And I and I don't have time to write it tonight, I don't think, so that's mainly, but I'm like, it'll give you guys an extra day anyway, so so the quiz will be Friday, it's fine, and then I'm going to move the notes that we were doing on Friday to tomorrow, so you'll still have some notes on Friday. I'm going to break it into 2 pieces. Instead of one long video, it's going to be like 2 shorter videos. So, all right? Sound good? That's it for notes today. Go ahead and put your notebooks away. We're doing something else now.